All right, lesson number 21, Math 87, lesson number 21, page 116. Prime and composite numbers and prime factorization. Okay, prime and composite numbers. When we have numbers, good 8. Okay, prime numbers and composite numbers. Prime numbers are only divisible by 1 and themselves. Prime numbers are only divisible by 1 and themselves. That's prime. Okay, composite numbers, that's a P. Composite numbers are composed of more factors than 1 in themselves. So the first number up here, number 1, is neither prime nor composite. This number here, it doesn't fit here or here. So 1 is not prime, it's not composite, it doesn't fit either place. The number 2 is the only even prime number because the only factors of 2, it's divisible by 2 and 1. That's it, no other numbers. That makes it a prime number. The next number is 3, that's a prime number. It's only divisible by 1 and 3. Next is 4, that's divisible by 1, 2, by 1 and 2, and 4. So 4 is a composite number. 5 is prime. 6 is composite. There are no even prime numbers except 2. If a number is even, it's always composite. All the prime numbers are odd, but not all the odd numbers are prime, okay? Next one we have is 7, divisible by 1 and 7. And we have 8 here. Now 9 is divisible by 9. It's 1 times 9, but it's also 3 times 3. That makes it a composite number, okay? As we go through here, you have to check the prime numbers to see if they're, the odd numbers, to see if they're divisible by more than 1 of themselves. All right? So prime and composite. Remember, 1 is not prime and it's not composite. Second part of this lesson is they want you to do a thing called prime factorization. A factorization is the answer to a multiplication problem. Okay, so if I have a number like, I don't want to do their number, I don't like their number. Let's just leave that up there. Okay, so I'm not going to use 1. Now we're going to do prime factorizations. So we're going to take out all the composite numbers here. Okay, we're going to take out the composite numbers. All right, so these are all just prime numbers here. All right, does that make sense? A little bit. All I have left up here is prime numbers. So if I take a number like 420, they do a thing in the book called factor trees. I don't do factor trees. If you'd like to do factor trees, you may grow as many of as you want. I don't like them. They confuse me. I know how to do them. I just don't like them. What I do is upside down division. Upside down division like this. You want to start with the lowest prime number that will go into this. Since it's even, 2 is the lowest one. You do it like this. 2 goes into 4 2 times. Just do one number at a time. 2 goes into 2 1 time. 2 goes into 0 0 times. It's still even, so I can still use 2. 2 goes into 2 once. 2 goes into 1 0 times, carry the 1. 2 goes into 10, excuse me, 5 times. Wow. I don't care. I'm going to leave that on there because I can. All right, now it's no longer even, so I can't use 2. Now, if I want to use 3, I can because 1 plus 5 is equal to 6, and that's divisible by 3. Or I can look at it and say I have a 5, and I can do that. Let's just do that. 5 goes into 10 2 times. 5 goes into 5 1 time. Now, this number here is divisible by 3. Excuse me, I'm entering adolescence. 3 goes to 21 7 times. 7 is also prime. So I can stop. Don't divide again because then you get 1. Don't care about that. Now, that's not the answer. The answer is the factorization, the multiplication problem. It's 2 times 3 times 5 times 7. I just put them in order. It doesn't matter what order they're in here, right? Because it's multiplication. This is the answer. That is the prime factorization. The factors made up of all prime numbers. All right, how about if we had 550? Now again, I'm going to start with the lowest prime number, which is 2, because that's even. 2 goes into 5 2 times with 1 left over. That's where the remainder goes. 2 goes into 15 7 times with 1 left over. 2 goes into 10 5 times with nothing left over. Now see, since I have a 5 here, I'm going to use 5 because I know it's going to go in there. 5 goes into 27 5 times. 5 times 5 is 25. So there's 2 left over. 5 goes into 25 5 times. 5 goes into here 1d1 times. That's a prime number. So my prime factorization is 2 times 5 times 5 times 11 equals 550. This is the prime factorization of that number. Okay? Let me just make sure there's nothing else they're going to do. Yes. Just on these practice here, make sure you do this strange and unusual thing, which many times y'all don't do. Read the instructions to see what it is they're actually asking you to do. Okay? Thank you very much.